Hey, physical science students, let's get right down to it and talk about energy. As a reminder, we are in lesson 11, which covers chapter 4 of your textbook. We're actually focusing on section 4.2, which covers pages 114 to 119, all about describing energy. So, what is energy? We talked a little bit about energy in a previous video when we talked about work, but your textbook describes energy as the ability to cause change or do work. Things do not change unless energy is involved. Energy is tricky to describe because it's not something that you can grasp, you can touch, but you can describe the effects of energy as things change, like motion, which we covered in previous videos. Before we talk about the types of energy, I want to make sure that everyone understands that energy is measured in joules. Doesn't matter the type of energy, the form of energy, it's measured in joules with a capital J as a symbol. So let's take a look at the different forms of energy. Notice I have the definitions written down here on page 116 of the textbook. The first type of energy is known as kinetic energy. We abbreviate it as KE. It's energy due to motion. Anything that is moving has kinetic energy. I'll talk about that in just a second. We'll talk about how to calculate that. Anything that's in motion has some sort of kinetic energy. There's another type of energy, however, called potential energy, which we abbreviate as PE. It is considered stored energy, or defined, excuse me, as stored energy due to the interactions between objects. Think about food that you might eat has potential energy. I'll talk more about that after. Think about something that's high off the ground that might soon be in motion has potential energy, and we'll calculate that as well. So here's the equation to describe how to calculate kinetic energy. Again, kinetic energy is energy in motion. We abbreviate it as KE. The equation is kinetic energy, which is going to be measured in joules, equals 1/2. You can also do 0.5 if you want to go that route. I like decimals better than fractions sometimes, but your book describes it as 1/2 times the mass and the square of the velocity. When something is in motion, you can describe its kinetic energy by describing how heavy it is, which is its mass, times the square of its velocity. And again, velocity includes speed and direction. Direction might not necessarily be included in these calculations, but I'm going to show you an example problem right now. As we calculate kinetic energy, I left the equation up here. I want to make note that mass, the symbol for mass is M, and that's going to be the unit for that is going to be in kilograms. Kg is the symbol. And the velocity, which we can also interpret as speed, is going to be in meters per second. But keep in mind, we're going to square this. We're gonna multiply this by itself first. We're going to square the velocity first. On page 116, I have example problem 4. A jogger with a mass of 60.0 kg, kilograms. That tells us that there is the mass right there. That's going to be M. This jogger with a mass of 60.0 kilograms is moving forward at a speed of 3.0 meters per second. There's our speed, which we can also call the velocity. There's no direction included. They're just moving forward. So don't worry about direction. Just understand that this is your velocity, 3.0, and 60.0 is your mass. What is the jogger's kinetic energy? Let me get my marker here and we will work this problem out. Again, Ke, kinetic energy, equals 1/2 mv squared. The first thing we need to do is substitute uh, our measurements in for these variables. So I'm going to rewrite it, if I can do this. It's hard being left-handed and doing this. Ke equals 1/2. We can call it 0.5 if you want to. 1/2, we'll do that. What's our mass? I'll put it in parentheses. Our mass is 60.0. 60.0. What is our velocity? Our velocity is 3.0, so we have to square that. 3.0 squared. We have to do this first. 3 squared, you can use your calculator if you want. 3 times 3 equals 9. You can refer back to this video, so I'm going to erase this for the time being. Basically, it's going to be, I'll put that in parentheses, 1/2 times 60 times 9. According to your book, and you can do all of this in your calculator, that is going to come out to be, let me check the book. Okay, the answer is 270, but what? 270 because it's kinetic energy, and energy is always measured in joules. The answer is 270 joules. You can write it with a symbol of a capital J. Let's talk about potential energy next. So there are some subcategories with regard to potential energy. Again, potential energy is stored energy due to the interactions of objects. Your textbook lists them, the three subcategories of potential energy, as chemical potential energy, elastic potential energy, and gravitational potential energy. I will try to describe those as best I can. The first one is chemical potential energy. Chemical potential energy, I want you to think of it as food. Why do we eat food? We eat food because we need energy. And when we digest that food, and when chemical bonds are broken and reformed to make new products, energy is released. So when you think of an apple sitting on a table, that apple has chemical potential energy. The next one is elastic potential energy. I have one of my daughter's hair pretties here to describe this. Elastic potential energy describes how you can increase the amount of potential energy, again, stored energy, as an object is stretched. So if I start to stretch this object, I am increasing the amount of potential energy. It's almost like a bow and arrow. And I'm going to let this thing fly. Hopefully my dog doesn't eat it, but notice there is a very large amount of potential energy, elastic potential energy, in this situation versus this situation. It's still stored. There's no motion yet, but when that is transferred into kinetic energy, there's quite a bit of elastic potential energy in this particular situation. There it goes. The last one is gravitational potential energy, which basically depends upon an object's position. Here's my whiteboard marker here. Imagine that the object is this high off of the ground. My table is right here. It has a certain amount of uh, potential energy. If I raise that higher and I change its position, I'm going to have a higher amount of what we call gravitational potential energy. There is an equation that we use to calculate this, and the video will conclude with this particular with an example from the textbook. Here is the equation for gravitational potential energy, which we abbreviate as GPE, gravitational potential energy. GPE equals the mass of an object, notice I put the units in kilograms, multiplied by the gravity. Gravity is measured in newtons per kilograms. We'll talk about that when we do the example problem, times the height in meters. All of this is multiplied together. Gravitational potential energy measured in joules, because it's still energy, equals mass times gravity times height. If you want, I can put couple dots or X's if people like that, but all of those are multiplied together. The sample problem is on page 119, example problem 5. Here is example problem 5 on page 119 of the text. We're still describing gravitational potential energy, GPE. We're going to calculate it. Here's the problem. A 4.0 kilogram ceiling fan. Let's stop right there before we go any further. 4.0 kg. There's our mass. There's the mass. 4.0 kilogram ceiling fan is placed 2.5 meters above the floor. Let's look at this measurement right here. This particular measurement in meters is our height. It's above the floor. So we now have, let me see if I can do this here. We have our mass and we have our height. The rest of the problem doesn't exactly help you out with gravity, but think about the fact that we're on planet Earth, and if you remember from previous lessons, previous chapters, previous videos, gravity. I'm going to write it up here in the corner. Gravity on the surface of planet Earth, due to its mass, is 9.8 meters per second squared. You could say newtons per kilogram. Gravity's 9.8. Okay. So if we apply all of this to our equation for gravitational potential energy, we're going to multiply the mass, which is 4.0, times gravity, which is 9.8 on planet Earth, times 2.5, which is our height. So we have, let me plug this in here, 4.0, you could say 4 if you want, times 9.8, which is gravity on Earth, times our height, which is 2.5. All of those multiplied together will give us our gravitational potential energy. Keep in mind that gravitational potential energy is measured in joules, and I'm just going to grab my calculator so I can make sure we have the correct answer. Our gravitational potential energy, our GPE, equals all of this multiplied together, 98, but keep in mind it's energy. Energy is measured in joules, whether it's kinetic or potential. This ceiling fan has a gravitational potential energy of 98 joules. That is the final answer, and that is describing energy.